Google Cloud's Firebase hosts the entire cloud architecture. User input can be captured through any Bluetooth joystick controller or Android app. Alternatively, 13.1-inch touchscreen running Raspbian or Android OS on Raspberry Pi 4 can be used.
User input is sent to Firebase's real-time database. ESP32 receives the update in real time whenever a value changes and drives the robotic arm or excavator accordingly through a 2C communication protocol. When battery is disconnected, ESP32 reports fake crash and request to raise Jira tracker, and new issue is opened on Jira by Google Crashlytics.
Developer can manage the whole system through command line interface or web console of Google Cloud. Now let's understand the CI/CD pipeline for building the software for ESP32. Whenever developer push the final changes into the master branch of ESP32 GitHub repository, it triggers Git workflows defined based on Git actions script file pushed along with the code. The GitHub actions now create and deploy container either on GitHub hosted runners or Docker container or Google Cloud Engine container. Each container has different OS to choose from Linux and Windows, built and configured with images of all the required software and platform tools required to compile and build the final binary file for ESP32. The generated binary file is then uploaded to the Google Cloud Storage bucket. The binary file is then deployed to ESP32 over the air. ESP32 reboots after downloading new firmware.
Let's quickly watch a demo of CI/CD pipeline in real. On the left side of the window, we have our GitHub Actions workflow file. This workflow file contains set of all actions to be performed when code is pushed to GitHub. Let's commit and push our code to GitHub with one-click shortcut. Let's enter the commit message JLR virtual demo CI/CD run and push the code to GitHub. This push to GitHub will trigger an action workflow. Let's go to the GitHub Actions. We can see a new workflow just created with the commit message we entered before. Let's observe the workflow started. The main goal of this workflow is to compile and build software for ESP32. In first step of our workflow, we have created Linux OS-based runner as part of setup job. After that, we are checking out our GitHub repository to fetch all the code files. We then set up global constants, environment variables and Python 3.10. The next workflow step installs all the required Python libraries and dependencies, including Google Cloud's Firebase admin libraries. Workflow then decrypts all the stored credentials to be used for next steps. This step helps us to keep all our credentials, app secrets and token files safe, secure and encrypted while uploading them to GitHub. Workflow then downloads and installs all the required core and firmware header files to build software for ESP32 modules. This includes all the input-output driver files, real-time operating system files, modules configuration files, Google Cloud Firebase header files for ESP32, Adafruit PWM servo drivers. Workflow now starts compiling all the C code and header files to build final software binary file. It takes roughly under a minute to compile and generate final software file. When finished, user can see the generated sketch file size. Workflow then calculates checksum and compares with previous versions checksum and then upload the software to Google Cloud bucket. Workflow then notifies ESP32 excavator about new software uploaded through Google Cloud Real-Time database. As you can see in the left side of screen, ESP32 starts downloading the newly uploaded software from Google Cloud bucket as soon as it receives the notification. ESP32 downloads the software in a partition reserved for this purpose, and once downloaded it restarts and reboots from this new firmware downloaded. Let's check out the uploaded software file in Google Cloud Storage. You see the uploaded firmware with date and timestamp. This is the real-time database child node through which ESP32 was notified about new firmware. Google Cloud Firestore is used to save and log all the information related to software build under firmware collection with firmware name as document name. It has all the information related to firmware build with date and time, GitHub committer, email ID, commit link, etc. User can use this link to go back to the GitHub commit for this software build and inspect all the changes for that commit.